the second video in this playlist, we will address the usage of the Xilinx tools and more specifically of the project Navigator, which we will use many times throughout this course. We shall start with a new project, so in case there is a project already open, we shall start by closing it and then select New Project. We might just call it project taking place at year 13, month 9, day 18, version B, for example. We must make sure that the project settings are in accordance with the Nexus 3 board that we are using, namely the device and the speed. And if this is correct, then by clicking on Finish, we will have created our project, and we are now able to add a new source, which might be a VHDL module that we might wish to call comparator, and then we could say that it would have two inputs, I0 and I1, and one output that we might call Actuate output. And by clicking on Finish, we would generate a VHDL description that automatically includes the entity description for this case. Well, in this case, we don't really need to create a new source from scratch, because the book comes together with the examples that are presented, so we can simply add an existing source, go to the file structure containing the listings in the book, and select the appropriate file. So if we open it now, we see that we already have the complete VHDL description for the 1-bit comparator present. Since this is the example coming with the book, we expect that we can synthesize it without finding any errors. And if that is the case, then we will be in the position of starting the simulation to check that it does what we expect it to do. Here it is, the synthesize process completed successfully. So notice that we have an implementation and simulation view, but actually what we need to know to do this in this case is to add a new source, which will be a VHDL test bench. So we can call it testbench underscore comparator, for example. It will be associated with this source, that is correct. So as soon as we click on Finish, we will have generated a new file that contains the appropriate structure for a simulation. However, if we look at the errors generated here, we see that it reports a number of errors, and these errors relate to the fact that we are using a combinational example which doesn't have any clock, but by default the test bench generator will consider the existence of a clock, so we have to remove everything that is related to the clock. We don't need this statement here as well. We can clear this part as well, and this is where we will insert our stimulus. In this case, what we will say is that we have an input I0 that we want it to take the value of 0, for example. Then we shall copy this to make it faster, and simply paste it and indicate that this will be I1. And in order to consider the 4 possible combinations, we can copy and paste this 3 times, and then change it in the second case to 0, 1, then to 1, 0, and finally to 1, 1. And we will have covered all 4 possibilities. We can now select the test bench and run the simulator after saving the changes that we have made. So it will start by doing a syntactical check, and if everything is okay, it will launch the simulator. We can zoom to the appropriate view, and as we see it here, if We start with two equal values on the two 1-bit inputs. The output is 1 as we expected. If the two input values are different, as is the case in the 0, 1 or 1, 0, then the output will be 0, and finally when they are again both 1, then the output will be 1. So the function is taking place as we expected, and we can continue with our implementation sequence. Before going on to the implementation and generation of the programming file, we shall create a user constraint file, and this file shall be in accordance with the connections that are present in the Nexus 3 port. If we use the two least significant switch inputs for bits I0 and I1, and if we use the least significant output connected to the LEDs to show us the result of our comparison, then we shall connect switch 0 to T10, I0 to T10 and I1 to T9. In order to do so, we can go back to the project Navigator, and in the user constraints launch the plan ahead tool. We could, in this case, also create the user constraints file manually, and it would probably be quicker and give less work, but then by using the plan ahead tool, we will have the opportunity to see how this tool works and to familiarize ourselves with the view that it offers us. So as soon as it is launched, we will be able to allocate the existing signals to the pins as we wish it to use them. And please bear in mind that we want to connect input I0 to T10 and input I1 to T9. So we can close this initial message. This is the layout of the device, and what we have to do is to take one of the inputs and then drag it to the appropriate place. So if we wanted to allocate it to T10, this is what we had to do. Then we would take the other input and repeat the operation, allocating it to T9. And then what we need to do is to allocate the output to U16. So we take the output and drag and drop it to U16 there. And now what we have to do is to save our constraints, and we can leave the plan ahead tool. And if we go back to the project Navigator, you will see that we now have a user constraints file that contains precisely this information. So we are now able to continue with our process, and namely with the implementation stage. The implementation, as you know, consists of these 3 steps: translate, map, and place and route. Everything going well, we shall complete successfully all these steps, and when that is the case, we shall be able to go into our last step, which consists of generating the programming file. So the map has completed, place and route is taking place now, and after the completion of this step, we will be able to conclude the design of the 1-bit comparator by generating the programming file. We would then transfer it to the Nexus 3 board and see it in operation, and this will not be included in this video, but simply consists of connecting the board running the adapt tool and transferring the file. So if we go to the last step, which is generate programming file, it is taking place and should be ready in a moment. And when it is ready, we can actually go and see what is the file that has been generated to be transferred to the Nexus 3 board. Programming file has completed successfully, as you see here. So if we open Windows Explorer, we go to Designs, and the project that we have created is here, and here is the file that we will transfer to the Nexus 3 board. Transferring this file, as I said, simply would require to run the adapt tool and select this file and click the program button.